All right, today we're going to talk about the 9.4, section 9.4, converse theorems of parallel lines. No worries. Converse just means the other direction, turning around what we said before in 9.3. So let's do a little bit of reviewing here before we move on to any kind of new theorems. So looking at the picture here, you'll notice a couple of things here. You'll see that they put arrows here. That's interesting. Arrows save us time from telling us that these two lines, A and B, are parallel. So if you ever see a set of arrows on two lines that appear to be parallel, it's because they are. There you go. So let's go ahead and go through this picture. I'll zoom in a little bit more so you can see it better. All right, so the whole name of the game here is not, you don't have to go in order. We'll go in order when we can, but we don't have to. So let's go ahead and build this thing up. The first thing I notice is angle 1 right here. This angle right here is directly across from 110. I know what you're thinking, vertical angles. Yep, and vertical angles are congruent. So if the first one's 110, so is the other one. All right, well, let's keep going. Angle 2, angle 2. I don't want to do 2 yet. I like 4. Let's go ahead and do this as well. If you could go ahead and write the 110 on the picture, then you'll see what we can use. Notice how 4 is right next to the 110 on either side. So you could go with these two angles, form a linear pair, or are supplementary, right? Or these two, it doesn't matter. Since they are sharing the same angle, we know angle 4 is the missing part of 180, and that is 70 degrees. So I'm going to write 70 degrees for angle 4. All right. Now I'm ready to jump back to angle 2. I'll show you why. It's a little hard with these extra lines drawn in. It's like a couple transversals. You got this one here and you got this one here. This angle here is exactly in the same position as this one. You remember that was corresponding. And corresponding angles with parallel lines are going to be congruent. So we know that those are 70. So I'm going to mark this one 70 degrees. I still need 3 and 5. 3 and 5. Well, let's look at 3 next. I see 3 is located right next to the 50. So there's another. Anytime you're on a line, that totals 180 degrees. We have 50 here. We just need an additional 130 to finish it off. So 130 degrees would be angle 3. All right, all we have left is 5. What is 5? You know what? Let's try a little something crazy here. The angle next to the 130, that would also be supplementary, a linear pair, or straight across from 50, a vertical angle. Either way, they're going to be 50, however you want to do it. Then, if that's 50 degrees, isn't angle 5 and this 50-degree angle, aren't they corresponding? They're in the same position. So those are 50, and angle 5 is 50. So you'll soon discover there's not just one way to do these. You can actually see them in more than one way. And we don't have to do it in all the different ways. We just have to find the solution, find the angle, and we're there. All right, so today's all about converse theorems. Converse theorems. Let's talk about what that means. So the original theorems we talked about in 9.3 were based on these guys. Corresponding angles, alternate interior angles, same side interior angles, and alternate exterior angles. What we said in 9.3 was if two lines are parallel, then corresponding angles are congruent. If two lines are parallel, then alternate interior angles are congruent. If two lines are parallel, then same side interior angles, you might remember that one, are supplementary. They're adding up to 180. And finally, if two lines are parallel, then alternate exterior angles are congruent. Well, what we want to do is we want to turn this around just like an argument. But you said, so if we turn this thing around and say, hey, we know corresponding angles are congruent, corresponding, oops, sorry about that, angles are congruent, then we know we have parallel lines. If you might recall, if you don't know this, I'm going to save you a lot of time right now, guys. This symbol means parallel. So parallel, it's not an 11, it's the symbol for parallel, just like perpendicular is an upside down T. So I'm going to write down corresponding angles are congruent. We have parallel lines. That's all we have to do. All right. So none of the rules have changed. None of the angles have changed. It's just how we present them. So the next one, if we have alternate interior angles are congruent, then we have parallel lines. So now what we're saying is if you don't know if the lines are parallel, all you have to do is find the relationship of the angles. And if the angles come out to be the way we learned them before, then we can assume the lines are, in fact, parallel. All right. So this next one, same side interior. So same side interior angles, and we said those were supplementary, right? Supplementary, sup. Then we have parallel lines. So if you have same side interior angles supplementary, you have parallel lines. So these are a bunch of ways to show that two lines are in fact parallel. All right, last one. We have alternate exterior angles. Alternate exterior angles are congruent. What do you think? You got it. The lines are parallel. So therefore we have parallel lines. So that's it. So if you ever want to know if two lines are parallel, just check the angles. If the angles, the corresponding angles are congruent, or the alternate interior angles are congruent, or the alternate exterior angles are congruent, then the lines are parallel. And if the same side interior angles are supplementary, we also know the lines are parallel. All right, let's get on some bigger, better stuff here. Remember, you can pause this video anytime if you're not keeping up. You want to double check it and come back. Here we go. Page 2. All right, let's pick up from there. So now let's go ahead and see what happens when we have a picture with some values on it. Aha! So here's the question. Are these lines parallel? They're not marked that way, but we want to make them parallel. So what kind of angles are these? They're on the interior of these two lines. They're on the interior. So they'd have to be on the same side. So I'm going to go with same side interior. So I know that same side interior angles must be supplementary. So if I want these lines to be parallel, then this better be true. So I have 1x plus 4x's is a total of 5x's, and that's 180. And then I would just divide by 5, split the line down the equal sign, and I would have x is equal to, well, what's 180 divided by 5? Well, 180 divided by 5 is going to be, I believe, 38. Did I do that right? Let's see, 4. Yeah, that's right. So we're going to go with 38. Is that 38? No, what did I do there? 180 divided by 5. I didn't bring my calculator. Maybe it's not right. Let's check it out. That's 15. 36. 30. So that's going to be 36, which is in fact what we wanted. Okay, so I'm going to go back here and change that. Sorry about that. 36. Okay, so let's go ahead and check out the next one. So that would now prove that those lines are parallel. All right, next one. So again, the name of the game on all of these is going to be what kind of angles do we have? Here's an angle. Here's an angle. These lines are not parallel yet, but we're going to make them parallel by making these angles relate. Well, those sure look to me like corresponding angles. I'm thinking I may just remind myself so I can study that. Corresponding angles, cool. And I need those to be congruent. 2x plus 1 better be equal to 3x minus 5. Line down the equal sign. All right, my class likes to combine the like terms, but the only way to combine them is to take them across. So how do I get a 2x out of here into the other side? I subtract it. I'm going to subtract 2x. So if I subtract 2x, those cancel. I have 1 equals, that's a 1x minus 5. Then I can go ahead and what? Subtract 1. Get some more space here. Subtract 1 and subtract 1. The 1's are gone. Don't forget, on the left side is now 0. Uh-oh. I have 1x. Negative 5 minus 1 is negative 6. I kind of went about this a little different way. That's okay. We're going to add 6 to each side so we can get rid of that 6. And when I'm done, 6 plus 0 is 6 and 1x. And if I wanted to keep going, I could certainly divide by 1, but that's just 6. So x equals 6. So to review one more time, if you put in 6 here, you'd get 3 times 6 is 18, minus 5 is 13. Okay. And if you put in 6 here, 2 times 6 is 12 plus 1 is also 13, and that's what they're supposed to be. Corresponding angles will be congruent, and those lines will then be parallel. All right, let's check out another one. What would make these lines parallel? Well, more of the same. What do we got here? We've got 2 angles. Looks like they're corresponding again, and if they're corresponding, we know we want them to be congruent. X plus 10 equals 50. Little subtraction here. We'll get rid of that 10. And I'll have x is equal to 40. So that is my final answer. So if x was 40, I would then have those lines parallel. All right. Ooh, what are these? All right. So these angles, this angle here and this angle here, are on the interior of these 2 lines, and they jump across. So we don't have an opposite, we have an alternate. Yeah, that was alternate. I'll write that down again. Alternate interior angles. That's what we got there. And we know that those are supposed to be congruent if the lines are parallel. So I have 8x plus 5. I'm going to put this 10x minus 7 on this side. It doesn't matter which side you put them on. I just like to put the bigger number, the bigger x on the left. You'll see why in a minute. All right. So I'm going to go ahead and combine my like terms. The x's could be combined if I subtracted 8x from each side. That would bring it from the right to the left. 10x minus 8x is 2x. Subtract 7 is equal to, well, the 8x's are gone, so that's just 5. Then I believe we could add 7. And if we add 7, we'll have 2x is equal to, what's that, 12? A little more space here. We can finish this. Oh, not much space left. Divide by 2. And x will equal 6. So once again, if I put in 6 into these 2, I'd have 8 times 6 plus 5. That's 48 plus 5 is going to be 53. And then I'd have 10 times 6 is 60 minus 7 is also 53. And I know those lines would then be parallel. The top and bottom lines would be parallel. All right, let's try this guy. Oh, this one looks different. They don't look the same. I don't think we want them the same. We want to make sure that these 2 lines become parallel. So once again, they won't be parallel until these 2 angles are related. Let's see what kind of angles they are. They are on the interior and on the same side. I think I just answered your question. They are on same side interior angles. I run over interior angles. That's an angles, really. Okay, so we know that same side, remember we said they're not equal. The only thing they could be if they're not equal is supplementary. 5x minus 8. So we got the first 2 and the last 2. It has to equal 180. Now we can just go ahead and combine like terms. They're on the same side. 3x plus 5x is going to be a total of 8x. Then we've got 20 and negative 8. So 20 plus negative 8 is 12. And then we bring down our 180 and we're ready to go. All right, so now I want to get rid of that 12. So I'll subtract 12. And if I subtract 12, all I have left is 8x is equal to. So 180 minus 12 is going to be 168, I believe. And then if we divide by 8 to finish this off, 8's cancel and x will equal, well, 16 divided by 8 is 2, 8 divided by 1, 8 divided by 8 is 1, that's just 21. Check me on your calculator, make sure I did that right. So x equals 21. If x was 21, these two angles would be supplementary like they're supposed to be, and these lines would be parallel. All right. Last one on this page. Here we go. All right. Ooh, we haven't had this one in a while. What kind of angles are these? Well, looks like they're outside the two lines, which means they're exterior. That's perfect. There's no same side exterior. You don't need to worry about that. They are alternate exterior. So again, alternate exterior angles. All right, alternate exterior angles. And we know alternate exterior angles, check your notes, are supposed to be congruent. So 2x plus 10 better equal 80. So if I subtract 10, 10's cancel, and I have 2x drops, and 80 minus 10 is 70. Then I can go ahead and divide by 2. 2's cancel, and x will equal half of 70 is 35, and I think we got this. So again, if x was 35, the two lines would be parallel. All right, so let's check out this last page, see what we got. Oh my gosh, do I have good news for you? That was the last page. What a deal. So that was notes for 9.4. If you have any questions, remember the converse allows us to work backwards. Make the angles have that relationship, then the lines will be parallel, and that will follow. So that should do it for today. If you have any questions, talk to your teacher. Have a great day. See ya.